Kinematics. Google defines kinematics as the branch of motion concerned with the motion of objects without reference to the forces which cause the motion. Not exactly a very helpful definition for a newcomer to physics. So, instead of trying to learn what kinematics is based on its definition alone, let's focus on understanding it first, then coming up with our own definition. In this video series over kinematics, we will introduce the essential concepts of kinematics, and then derive and understand the equations that govern it, ultimately coming to a good understanding of the topic. This video will be the introduction to the concepts of kinematics that must be understood before diving into the equations and practice problems. It will cover three main concepts: distance versus displacement, speed versus velocity, and acceleration. Let's get started with distance versus displacement. Let's use something we can model motion with: Sonic. Never mind, we'll just use Sonic instead. Let's say Sonic is standing at the very top of the world, and then runs around the entire world. For simplicity's sake, let's say that the circumference of the world is 100 meters. Definitely realistic. First, we can figure out the distance that Sonic traveled. Distance is simply the amount of space that an object has traveled. So, Sonic has traveled around the world, and we know that the world's circumference is 100 meters, so the distance that Sonic has traveled is 100 meters. Displacement, however, is a bit more complicated. Displacement is the amount of space between an object's final position and its initial position. As you can see, when Sonic runs around the world, his initial position and final position are the exact same, so his displacement is actually 0 meters, even though Sonic traveled all around the entire world. Another cool thing about displacement, and what makes it really important, is that it is a vector quantity. Distance is a scalar quantity, which only has magnitude, which is basically the value associated with it, like 100 meters. However, displacement is a vector quantity, meaning that it has direction as well as magnitude. This means that it can be negative or positive, depending on which direction is decided to be negative and which is decided to be positive. That's all cool and all, Mr. Disembodied Voice on the Internet, but why is this important? Well, inquisitive and descriptive viewer, to answer that we must look to our next concept: speed versus velocity.
Speed and velocity are similar, but there's a reason they're two different words. To understand this, let's say Sonic ran the 100-meter race in just 1 second. That means he's running at 100 meters per second, which is his speed. For speed, it doesn't matter if he was running towards or even away from the finish line. This is because the formula for speed is distance over time, and both values have no direction. The only thing that matters is how far he ran in a certain amount of time. Now, on the other hand, velocity is a vector, meaning direction actually matters. This is because the formula for velocity is displacement over time, and displacement is a vector that has direction. Since displacement is in the formula, this makes a velocity a vector as well. Now let's say Sonic started his daily jog in the middle of the country of Brazil, facing eastward, which we'll call positive. If he keeps his direction and runs east for 50 meters in 2 seconds, his velocity, 25 meters per second, would be positive. But if he did a full 180 and ran the same distance in the same amount of time, but westward, his velocity would now be negative 25 meters per second because of the negative displacement. So in conclusion, velocity is just speed, but with a direction attached to it. So instead of 25 meters per second, you would say 25 meters per second eastward. However, let's say that you're running. It's really difficult to run at the exact same speed for an entire 10 minutes. That's why we have something that measures when our velocity changes. This is called acceleration. Now, a lot of people might have heard the term acceleration and know it occurs when something like a car speeds up while driving. While that is acceleration, the topic is actually more broad. Acceleration is defined as a change in velocity. Now, we've established velocity is a vector quantity, meaning it has both magnitude or a value and direction. Since acceleration is a change in velocity, this means acceleration is not just when its magnitude, which is when it speeds up or down, changes, but also when it changes direction. For example, say Sonic was traveling at 10 miles per hour down a road and made 2 right turns, but didn't slow down or speed up once. If his speed didn't change, was there acceleration? There was, because the direction changed. Although this may seem counterintuitive, there really was acceleration because the direction changed, and so the velocity changed. Now, because acceleration is a change in velocity, it is calculated by finding how much the velocity of something changed over a period of time. Once you understand it, it's pretty simple. Say Sonic started at 20 meters per second running down the road, but then saw a restaurant ahead, so increased his velocity to 100 meters per second in just 2 seconds. So what would his acceleration be? To find the change in velocity, we would subtract his initial velocity from his final. Then we would divide that change by the change in time to find the acceleration. So for this situation, we would do 100 minus 20 all over 2 seconds. This gives us an acceleration of 40 meters per second divided by seconds. Or this can be rearranged as 40 meters per second squared. So those are the 3 basic concepts you need for kinematics. Next video, we will apply what we learned in this video to solve problems using the kinematic equations.